This is Algebra 1, Lesson 39b, Negated Inequalities. We're doing examples 39.1 and 39.2. But first, let's consider x. And what is this? Underneath that slash, you can see a greater than. So if it said x is greater than 10, we would know what that means. But when you put a slash through it, it's like when you put a slash through an equal. We could say 5 is not equal to 7. This would be read not equal. So in a similar fashion, you can read this as x is not greater than 10. So that'll help us interpret that a little bit. X is not greater than 10. The book doesn't ask us to, but I want to look at this visually. This tells me that x is not greater than 10. Here's what greater than 10 would look like. It would be all those numbers. So if it's not greater than 10, then it would have to be equal to 10 or less than 10, right? It could be less than 10. So I'm going to erase where I wrote on this side. That would be the other, what this would mean. Because in our trichotomy axiom that we learned about in the last video, we know there's only 3 possibilities. When you're comparing numbers, they're either going to be equal, or one's going to be greater than the other, or it's going to be less than the other. So we have 3 possibilities, and they just told us that x is not greater than 10. So it must mean that x is either less than or equal to 10. So the book's not asking you to graph it. I just graphed it so you could kind of see what I was thinking in my head. But they may ask you to write it as an inequality, not a negated inequality. So this is a negated inequality because they've said it's not greater than, okay? So let's write it as an inequality then. If x is not greater than 10, then it must mean x is less than or equal to 10, just like we saw in that picture that I just drew. Now let's try another way of thinking about this. If x is not greater than or equal to 6, then what must x be? Well, if it's not greater than 6, it must be less. And the equal was listed here, so it's not going to be listed here. We would say x is less than 6. These two would be talking about the same thing. But it's much clearer to understand if we look at it written as an inequality instead of a negated inequality. Let's look at example 39.1. Draw a number line and graph the solution of x is not less than 2. So for this one, they are asking us to graph it. Okay, not less than 2. So if I were talking about less than 2, it would be this, right? That would be less than 2. But it's not less than 2. So that must mean it's going to be greater than or equal to. So for 39.1, you're going to have this graph. It's going to be a filled-in dot on 2, and it's going to be shaded to the right. X is greater than or equal to 2, which means the same as this negated inequality. Example 39.2. Write both an inequality and a negated inequality that describe this graph. Well, I'm going to start with the inequality because I'm better with that. I've been doing that longer. So I would say my variable, and I'm going to choose x. It's shaded to the left of 3, so I'm going to say it's less than 3. And it's not shaded in on 3. If I zoom in there, you can see it's empty. It's an empty dot. So x is less than 3. Now, how could I write a negated inequality for that? Well, I need to write what x is not. So I can tell from this graph that x is not equal to 3 because they didn't shade it. So I could say x is not equal to 3. okay? And it's not greater than 3. So I would say not greater than or equal to 3. And I would show the not by just doing a slash through it. So x is not greater than or equal to 3. And we can do these problems because of what we know about the trichotomy axiom that we learned about in the last video. There's only 3 possibilities. A number is greater than the other number, or it is less than the other number, or it is equal to the other number.